Okay, so welcome to all of you. Welcome to all of you. Today we will see the change of order of integration. That means what? Suppose we have the integration like this: 0 to 1, y to y cube, sine of x cube, sine of x cube, y square, dx dy. These are the limits of x. These are the limits of x. That means we must have to integrate it. So we must have to integrate with respect to x now. Okay. So but here sine of x cube is not integrable with respect to x. This is not integrable with respect to x. We cannot evaluate this integration. So that means, but this integral is what integrable with respect to y. Easily you can integrate with respect to y. So to do this, what we have to change the order of this integration. That is what we cannot integrate this with respect to x. We want to integrate this with respect to y now. But so what we have to change the order of integration. Now here what the limits of y are limits of x are given. So we have to write the limits of y. That means what here your region of the integration is bounded by. These are the limits of y now. These are the limits of y. These are the limits of x now, right? So that means what the region of the integration is bounded by y is equal to 0, y is equal to 1, x is equal to y, and x is equal to y cube. You have to draw the region now with the help of this, with the help of these limits. Okay. So and then what? This is what the limits of x. That means their strip is parallel to their strip is parallel to x-axis. Our strip should be the parallel to y-axis, right? So for this, their strip is parallel to x-axis because these are the limits of x now, okay? And these are the limits of y. Y are constant. That means the strip is parallel to x-axis, right? So and your strip must be parallel to y-axis now, right? So we want to draw the region, right, where we get these limits. So we draw the region, and if the strip is parallel to x-axis, so we draw the strip parallel to y-axis, and we change the order of integration, right? So we solve problem so that you will understand how to change the order of integration, how to draw the region. So here what the region is very important. To draw the region is very important here, right? You should draw the line, parabola, circle like this. Okay. So we'll take the problem so that you will understand this. Okay. Change the order of integration. Change the order of integration 0 to 1, 0 to y, f of xy, dx dy. Only you have to do to change the order of integration only. So here a function is not given, so no problem the integration here. Okay, solution. Let I is equal to 0 to 1, 0 to y, f of xy, dx dy. So these are the limits of x now. These are the limits of x, right? So we want to change this as limit of, these are limits of y, these are the limits of x. So we want to here the limits of x and limits of y here and limits of x here. Okay. So here d is bounded by what these are the limits of this, what y is equal to 0, y is equal to 1, x is equal to 0, x is equal to 1. Okay. So we'll draw the region. Okay. So we'll draw the region. Okay. So a y is equal to 0 means this is what y is equal to 0 means x-axis. This is y-axis. This is your origin. Okay. So y is equal to 1. This line is y is equal to 1. Okay. So now x is equal to 0 means your y-axis. Okay. Now line x is equal to y. This is what passing through this. Okay. So this is y is equal to x and this is y is equal to 1. Okay. So we find this point of intersection here. So y is 1 here because what everywhere your y is 1, right? So that means this y coordinate is 1 here. So if y is 1, this point is 1 1 now. We will need the point of intersection. Now see which region now. This y is equal to 1. This will be your region of the integration. This will be your region of the integration. Okay. Now see here. See here. So whether this region is correct or not, we'll check here. Their strip is what? Parallel to this is what? Their strip is parallel to x-axis. Their strip. So I will not just write this. What? Is it correct? We'll check only this. Okay. Now limits of y what? 0 to 1 is there. Limits of x from the left curve is 0. Yes. X from the left curve. And x from the right curve is what? X is equal to y. 0 to y. That means our region is correct now. So in order to change the order of integration we will draw strip parallel to y axis. We will draw strip parallel to y axis. Then the given integral can be written as I is equal to. Okay, so it is easy, right? So what is the limits of x now? Limits of x are what? So here what? Here, right? Limits of x is what? 0 to 1, lies between this, right? X lies between 0 to 1. Okay, so 0 to 1. Then what? Y from the lower curve is what? X. And y from the upper curve is 1. This is what? F of xy dy dx. Okay. Now see here. Order is changed. Okay. So your problem is over. Very simple problem, right? So your order is changed here, right? So now function is not given. So otherwise what? If function is given, then we have to integrate this then. We'll take the second problem. Change the order of integration. Change the order of integration in the order of integration. 0 to 2 x square to 4 f of xy dy dx. Okay. Okay. Solution. Let r is equal to 0 to 2 x square to 4 f of xy dy dx. Okay. The region of the integration d is bounded by. Okay. So these are the limits of y now, bounded by y is equal to 0, y is equal to 2, these are the. This is the function of x. That means these are the limits of y. And these are the limits of x, bounded by x is equal to 0, x is equal to 2, y is equal to x square, y is equal to 4. Okay. Now we'll draw the figure. So first we'll draw the parabola. So this will be your parabola. Okay. Now x is equal to 2. This is x is equal to 2 line. Just I will write here x axis, y axis, and origin. So this is what? X is equal to 2. I will write this point. This point is 2, and your y is what? 4. And then I have to draw the line y is equal to 4. Now see, y is equal to 4 here. That means this is the line also passing to this point. Okay. So therefore we need this point actually, right? So this 2, 4, right? So therefore what? Before drawing the line y is equal to 4, we have calculated the point of intersection of this x is equal to 2 and the parabola. So this is what? Y is equal to 4. Okay. So now your region of the integration. So we'll check whether this region is correct or not. Just we'll by trial and error we will draw this. Okay, we'll draw this region. Okay, so now their strip is what? These are the limits of y. That means their strip is parallel to so see, their strip is parallel to x axis. Now we'll check whether this is correct or not. Limit of x is what? 0 to 2. Yes, 0 to 2. Limits of x are clear. And limits of y what? Parabola to line. Yes, parabola to line. Right? So that means our region is correct. So we'll draw this. What? This is our region. Our region is correct. Okay. Now what we have to do? So we have to draw their strip is parallel to y axis. So our strip should be the parallel to x axis. In order to change, in order to change the order of integration, draw strip parallel to x axis, we'll draw strip parallel to x axis. Okay. Now then the given integral can be written as I is equal to, so what? Your strip is parallel to x axis, just write the limit of y first. Your y is what? 0 to 4. Then what? X from the left curve and x from the right curve. X from the left curve is what here? It is what? 0. X from the left curve, x is equal to 0. And equation of this is what? X. So this is what? Root y. We are in the first quadrant. You have to take the positive root. So root y. F of xy dx dy. See, order is changed here. Now see here, limits x equal to 4 and here what? 0 to root y. See the difference. So both value is same number, right? If your function is given to you, then the value will be the same, right? So when we have to apply this, so when your function is not integrable, right? Then what? So you have to integrate this with respect to y. Your function is not integrable with respect to y, then we must have to change the order of integration. Otherwise, if it is possible to integrate this, then what? Just integrate this. Because what here? If you want to change the order of integration, you have to draw the region and you have to change the order of integration, and then you have to solve the integration. If it is easily solvable or because some complicated also, but if it is integrable, then integrate directly this, right? But if command is there, solve this by reversing the order of integration, then you must have to change the order of integration, and then you have to solve this problem. Okay. Now we'll take one more problem. Change the order of integration. Change the order of integration. Change the order of integration. 0 to pi by 2. 0 to cos x. F of xy dy dx. Okay. Solution. Let I is equal to this. Okay. The region D of integration bounded by. So now this is the function of x, that means limits of y, and these are the limits of x now, bounded by x is equal to 0, x is equal to pi by 2, y is equal to 0, y is equal to cos x. Okay. Now we draw the graph. This is your x axis, this is your y axis, this is 0. So suppose this is pi by 2 is here, and suppose pi is here. Okay. Now what? If x is equal to 0, see the graph of this. If x is 0, then cos is 1 now. Okay. And it is pi by 2 like this. So this is your graph of the cosine function 0 to pi by 2. Okay. So we draw x is equal to 0 means y is axis. We already draw. X is equal to pi by 2. We draw this line. X is equal to pi by 2. This is x is equal to pi by 2. This is the curve is here, y is equal to cos x. Okay, and y is equal to 0 means your x-axis. We have already drawn this. Okay, now see the region bounded by y-axis, x is equal to pi by 2, right? X is equal to 0, and the line. I think this will be your region. This will be your region. So we'll check whether it is correct or not. So see, these are the limits of y now. That means their strip is parallel to y-axis. See, if you draw the strip parallel to y-axis, then see your x is what 0 to pi by 2 is correct, and what this from this 0 to y from this the cos x. So their strip is parallel to y-axis, and our region is also correct. Okay. So in order to change, we have to draw the strip parallel to x-axis. So we have to draw the strip parallel to x-axis, right? In order to change, you have to write this. In order to change the order of integration, draw strip parallel to x-axis, then the given integral can be written as I is equal to. So your strip is parallel to x-axis. We have to write limits of y first. So this point is what? 0, 1. Okay. So your y will be what? 0 to 1 then. 0 to 1. Then x from the left curve and x from the right curve. X from the left curve is what? 0. And x from the left curve is what? Cos inverse of y. So f of xy dx dy. Okay. So now this is your solution of the problem. Okay. This will be your solution of the problem. I hope that you understand this one. Right. So if there is a graph sin x, then it is start from here. Then one. The graph of the sin x is start from here. Like this. This will be the graph of the sin x. Right? Because what sin 0 is 0. So it starts from 0. Your cos 0 is 1. Therefore we have started here and like this. Right? So same thing here. Cos, you know that the graph of the cos function is like this. Okay? Like this. Okay? Okay, so we solve one more problem. Okay, so very interesting actually this. Change the order of integration. 1 to 2, 0 to ln x, log x, that is f of xy dy dx. Okay, so let I is equal to this now. Okay, so here what? The region D of the integration bounded by, so these are the limits of y, and so these are the limits of x. X is equal to 1, x is equal to 2, y is equal to 0, y is equal to ln x. Okay, y is equal to ln x. Okay. So we draw the graph. So this is what? Y-axis, x-axis, and this is x-axis. Okay. So first we will draw this y is equal to ln x. You know that log 1 is 0. That means x is 1 here, then it will be 0. Okay. So the graph like this. So your graph will be like this. Okay. So it is passing through 1. So this point is what? 1, 0. This is very important. Point 1, 0. Now we will draw the line. X is equal to 1. So this is passing through this. X is equal to 1. This is x is equal to 1. Now then x is equal to 2. This will be x is equal to 2. This will be x is equal to 2. then y is equal to 0. Y is equal to 0 means it is what? X axis. That means see, now here what? So this is the your region. This will be your region. We'll check this region is correct or not, and then we'll finalize this. Okay. First we'll check. So now see, this is the limits of y. That means their strip is parallel to y axis. So then your limits of x is, this point is what? 2 0. X is 2 means this point is 2 0. Okay. Now see limits of x 1 to 2. Okay. This is correct. Now strip parallel to, that means what? Y from the lower curve. Y from the lower curve is 0. Yes. And y from the upper curve. Y from the upper curve. This is the graph of y is equal to ln x. So y from upper curve is ln x. So this is correct. Okay. Okay. So now we have to draw strip parallel to x axis. So we draw strip parallel to x axis. This will be your strip parallel to x axis. This is very important, strip parallel to x axis or y axis. Right? Without this, you cannot evaluate the limits of x and limits of y. Okay? So to change, in order to change the order of integration, draw strip parallel to x axis, then the given integral can be written as, this is very important, you have to write this, can be written as, because problem is only the change order of integration. Okay, so I is equal to, okay, we change the order of integration. So our strip is parallel to x axis. We have to write limits of y first. This y here. So here what? You need to find this point. So your x is 2 here everywhere. Okay. If x is 2, then this is what? ln 2 now. This is what? ln 2. Okay. So now your limits of what? 0 to ln 2. Okay. Then limits of x now. X from this curve, right? X from this curve is what? So e raised to y now. Because what here? Y is equal to ln x. So ln is, the base is e here. So if you want to find a value of x, you have to take the antilog on both sides. That means you have to take the exponential on both sides. Okay? Because you know that e raised to ln x is always x now. And e raised to minus ln x is always 1 upon it. You may write here f of x also. So e raised to ln f of x is f of x, and e raised to minus f of x is 1 upon f of x. E raised to minus ln f of x is 1. So remember that. So we'll apply this one. Here e raised to y now. Okay. So e raised to y. So that y, x from left curve and x from the right curve, that is 2 now here. So this is what? F of x y dx dy. Right. So this will be your solution. So I hope that you understand this. Okay. So now here what? Okay. So very important thing is what? To draw the region is very important here, right? So without this one, you cannot change the order of integration, right? And see here, we have seen these 3 problems. So to draw the regions are very easy, right? Easily we can change the order of the integration. So I hope that you understand this one. So solve at least these problems with independently, okay? So that you will understand how to change the order of integration. In the next part, what we will see, we have to evaluate the integration, right? You have to evaluate the double integration. Note that the command will be given or will not be given. So note that if your function is not integrable with respect to x, then you must have to change the order of integration. If there is a command evaluate this one, right? So that function is what? You have to integrate that x, but that function is not integrable. But the function is integrable with respect to y. We must have to change the order of integration, right? If the command is not given, change the order of integration. If the command is given evaluate, but that function is not integrable with x, but it is integrable with respect to y, we must have to change the order of integration, right? So without changing the order of integration, we cannot solve the problem. Okay. So now here what? If the command is given by reversing or by changing the order, evaluate this one, then what? Then it will be easy to you. So there is directly given that you have to change the order of integration. Okay. So even though what, suppose the function is integrable with respect to x, integrable with respect to y also, but order is given that we have changed the order of integration and then value. So we must have to change the order of integration and then we have to evaluate it. I hope that you understand this one. In the next part, we will see how to solve such a problem by changing the order of integration. Okay, thank you.